tree as this important data structure in dealing with document formats. And in dealing with the presentation of web pages, there's sort of an analogous data structure that we call the frame tree. It's sort of a bad name because frames have other meanings, but the frame tree is a lot like the content tree, except it's a tree that's representing that's more about what we're presenting than about the markup. So the object in the frame tree essentially represents what CSS calls boxes. And probably the key difference between the frame tree and the content tree is that the class hierarchy of the objects is based on the type of object that you're presenting. So the classes in the frame tree are things like a block box, or an inline box, or a table, or a form control. And the differences, and the class hierarchy is actually pretty complicated, but the relationships in that class hierarchy are based on how the things are presented, rather than what language the element is in and what APIs it has to implement. So the most common relationship between nodes in the content tree and nodes in the frame tree is a one-to-one relationship, in that a typical content node will have one frame to present that content node. But there are actually, that's not the only possibility. It's possible that a content node might not be presented at all, and therefore that it might have no frames. It's also possible that a content node might have multiple frames. For example, if something has the CSS overflow property set to scroll, which means that it would have a scrollable area inside of it and scroll bars, we end up using two frames inside of each other to represent that object. One that's visually the box that you can scroll inside of, and the other one that's visually inside the box that's being scrolled and that moves when you scroll. And then there are actually additional frames to represent the scroll bars on the side and the bottom. So there's actually a more common example of multiple frames for a content node that I want to get to in a minute. But within layout, there's sort of four main parts to layout, to the code that lives within the layout directory of Mozilla. And these four parts sort of always happen in the layout directory of Mozilla. These four parts sort of always happen in this order that I'm presenting them here, in that the first thing we do is compute style. Then we construct frames. Then we do reflow, which is computing the positions of the frames. And then we paint, which is actually drawing the frames onto the screen. But when I say they happen in order, that doesn't mean that we do all of the first one, and then all of the second one, and then all of the third one, and all of the fourth one. Because if you're doing something like incrementally loading a web page, as the web page comes in over the network, we display the content as it arrives. But for each piece of content that arrives, we have to do all four of these things in this order. And then if somebody makes dynamic changes to a page later on using script, we then again have to do all four of these things in this order to make that change show up on the screen. So I want to talk a little bit more about each of these four areas. So the style computation I could talk about for an hour, but I'm going to talk about it for 1 minute. It's the code that lives. What I mean by this is basically the code that lives in this layout style directory. which is, in some sense, responsible for implementing CSS, cascading style sheets. But really, it only implements CSS up to the point of what the CSS specification calls the computed value of a property. Because the CSS specification describes things like how you parse a CSS style sheet, and how you match CSS selectors, and how different rules cascade against each other to yield the computed value of each property. But then the specification also defines what each property means. So the code that does the style computation, that lives in layout style, does all of the things I talked about, except for handling what the property means. So the end result of this code is that the computed value of the color property for this paragraph is green. This code is not then responsible for doing the drawing in green. That's other code within layout. So the next stage is frame construction, where we actually construct the frame tree. So believe it or not, most of this code lives within one file in Mozilla, which I think is the largest file in the Mozilla source tree. I think it's about 13,000 lines now. There's actually a little bit related to it in the second file. And the basic process of frame construction is that you first create the style context, which is the object that contains the computed style data. So it's the style context is the output of the style system that I just talked about. And then, using some of the data that's in that style context, you create a frame. So you have to resolve the style before creating the frame, because some of the CSS properties might determine what type of frame you need to create. Because the types in the class hierarchy that's used for the node in the frame tree depend on things like the CSS display property, where if the CSS display property has a computed value of block, you construct a block frame. If its computed value is inline, you construct an inline frame. So we have to do the style resolution before we construct the frame. This frame construction code is then also responsible for updating the frame tree when there are changes made by script, or when there are additional changes made as we incrementally load the content. So a lot of the complexity actually comes from handling dynamic changes rather than handling just the simple initial process of resolve a style context and create a frame. So the third stage in layout is reflow, which is where we compute the positions for all of these frames. So the key point about frames that I didn't mention earlier, but I want to mention now, is that every frame has a rectangle. So anything that's more than just a rectangle is represented by multiple frames. So, for example, a typical paragraph is just a rectangle. But if you have, say, an A element, an anchor, which is formatted as an inline, and that anchor wraps across multiple lines, there's a piece of the anchor that's on the first line, and a piece of the anchor that's on the second line. And those are two different rectangles. And therefore, they're two different frames that are for the same content node. That was the other example of multiple frames for a single content node that I hinted about earlier. So the code that does the reflow is actually mostly part of the frame classes. So the block frame class has a reflow method that's responsible for doing the positioning calculations for